Chapter 13, D and E, we start looking at bigger matrices. Finding the determinant of a 3 by 3 is a little bit more complex than a 2 by 2, but it's possible. And I'm going to do a slightly different way of doing this than the book does. We're still going to relate this to the downward minus the up. Remember, these vertical lines mean find the determinant of this matrix. So I'm going to do my downward diagonal, AEI, and then I'm going to do BF, but there's not a third number in that downward diagonal. What we're going to do is we're going to rewrite the first column, ADG. So my second diagonal is BFG. My third diagonal, CD, and I run out of numbers again. I'm going to rewrite the second column, B, E, and H. Now my third diagonal is CDH. And now I can do upward diagonals also, GEC, HFA, and IDB. So I'm going to add up the downs, add up the ups, and then I'm going to subtract them. The book goes into a little bit different explanation, and either way is fine. It doesn't matter how you do it. You'll get the same determinant either way. So I want to find the determinant, and I want to find the inverse of this matrix, and I want to make sure that they are inverses. So I'm going to call this matrix A. The determinant of A, I'm going to rewrite the first two columns, 3, 1, 2, 2, negative 1, 1. So the determinant would be negative 3 plus 2 times 2 times 2 is 8 plus 3 times 1 times 1 is 3. Those are my three downward diagonals minus my upward diagonals. Negative 6, 6, and 6. So what I have is 8 minus 6, or 2. And I can double check this in my graphing calculator. I'm going to go back into my matrix menu. I'm going to edit matrix A. This is a 3 by 3. And I'm just going to put in my elements. And the calculator can find me the determinant of this. I'm going to go to my matrix menu, over to math, and choice 1 is determinant, and I'm just going to tell it which matrix to find the determinant of. Negative 4. That's not good. I made a mistake. And my mistake was right here. And this is where a calculator can come in very handy. You can find mistakes that you make. It should be negative 9. So negative 9 plus 11 is 2, minus 6 gives me negative 4. Now, for an inverse of a 3 by 3, there is no real nice way to do it by hand. And if you're ever asked to find the inverse of a 3 by 3, use your calculator. So I'm going to select that matrix that I just put in there, matrix A, and then I'm going to find the inverse by hitting this x to the negative 1 button. Just press enter. And I get these decimals, and these can turn real nice in fractions just by pressing the math key. And I can arrow over to see what the last column is. So here is my inverse matrix. To check to see if this is indeed my inverse, I need to show that this multiplies with the original one to give me the identity both directions. So I'm going to do matrix A times matrix A inverse and if these two things are indeed inverses, I better get the identity, which I did. Now I also have to check it the other way. So I'm going to start by putting in A inverse times A, and I get the identity this direction. Also remember, matrix multiplication is not commutative. You have to check this going both directions. That's what it means to check that they're inverses. So here is a word problem. it has three different makes of vehicles, P, Q, and R. They're located at yard A or B on either side of a city. And what we want to do is we want to write down some equations that relate these variables. So there's 20% of P plus 40% of Q plus 30% of R, which totals 46 cars. That's for yard A. At yard B, there's 40% of P, 20% of Q, and 50% of the R's, which give us 54 cars. We have three variables, we need three equations. We're also told that the total of P, Q, and R is 150. Now, using algebra, this can get kind of drawn out, solving a system of three variables, but using matrices, it can go pretty slick and smooth. I'm going to transfer the system to a matrix equation. The last row is going to be ones. Then I'll have P, Q, and R. Remember, this is A times X equals B. I'm going to pre-multiply both sides by the inverse. So from here, I'm just going to go to my graphing calculator. And I'm going to edit matrix A. 3 by 3. And in go my elements. Now I'm going to quit, and I'm going to edit matrix B. This is a 3 by 1. $46, $54, $150. And it doesn't really matter what order you wrote these equations down in, as long as you stay consistent in these matrices. Now to solve this, it's going to be A inverse times B. A inverse times B. So there are 45 of type P. There are 55 of type Q and 50 of type R. Much cleaner, much nicer than solving the system algebraically. Again, for your assignment, you need to understand how to use the technology, how to use your calculator, how to get this stuff in, because dealing with big matrices, it's a technology kind of thing. Work on these problems, pay attention to setting up these word problems, and being able to use matrices to solve these big systems of equations.